Okay, so today's presentation is going to be in lining solar with the retrofit market, and it'd be myself, Lydia. I'm the area sales manager for Greater Manchester for Marley, and Debbie Culshaw, who looks after the Northwest and North Wales. Okay, so today at this session, we're going to be looking at an overview of the PV market, solar panels available, so the PV and how it fits into retro products, and then we're going to have a quick look at some case studies and where our system's being used. Okay, so Marley's at the forefront of the roofing industry in the UK. We have over 100 years of roofing expertise and heritage, and we pride ourselves on offering a flexible and efficient service that saves our specified customers time and money on their projects. We understand the pressures specification teams face, such as tight budgets, changing regulations, complicated supply chains, and the need for sustainable buildings to support the net zero target by 2050. We also understand the importance of the role manufacturers play in supporting the industry with the latest information. Our commitment to quality is core to our business and shown through our ISO 9001 and BBA certifications. Health and safety and the environment are also high on our agenda, and again these are reinforced by our ISO 12001, 18001 and BES 6001 certifications. We are the only UK manufacturer offering all elements of a roofing system, including clay and concrete tiles, shingles and shakes, solar panels, roofing accessories, and BS 5534 compliant JB red button. And this complete roofing solution comes with an unrivaled 15-year guarantee, offering complete peace of mind. Other providers out there will offer you a full system, but they bring together different components from multiple manufacturers. The advantage of the Marley roof system is that all the components in our system are developed to work together and give you a tried and tested solution. Now we're going to have a look at how solar PV works. This diagram shows how it's all connected and helps you understand how the panels work. The sun gives off light even on cloudy days. The PV cells on the panels turn the light into DC electricity, and the current flows into an inverter which converts it into AC electricity ready to use. The current is fed through a meter and then into your home's consumer unit. Plug in and switch on, your system will automatically use the free electricity you've generated, then switch back to the grid as needed. Any electricity you don't use is then exported to the grid for others to use, or there's also the option to fit a battery to store the unused energy rather than exporting it to the grid using the Smart Export Guarantee. In terms of installation, installers will usually need to erect scaffolding to install the solar panels on your roof. Once this is up, the solar panels can be installed, and the time will be dependent on the size of the array. The inverter will usually be fitted in either a loft or a garage, and this converts the DC current your panels produce to AC current that you can use in your home. There will also be a generation meter so you can see how much power your panels are producing. Solar panels are made of a thin layer of semiconducting material sandwiched between a sheet of glass and polymer resin. When exposed to daylight, the semiconducting material becomes energized, and this produces electricity. All solar panels are made from silicon, but differ in the way the material is cut and treated. Importantly, they also differ in efficiency. The most popular panels within the UK market would be monocrystalline and polycrystalline panels. Monocrystalline solar panels are generally thought of as a premium solar product. The main advantage of the monocrystalline panels are higher efficiencies and sleeker aesthetics. To make solar cells from monocrystalline solar panels, silicon is formed into bars and then cut into wafers. These types of panels are called monocrystalline to indicate that the silicon used is single crystal silicon. Because the cell is composed of a single crystal, the electrons that generate a flow of electricity have more room to move, and as a result, these panels are more efficient than their polycrystalline counterparts. Polycrystalline solar panels generally have lower efficiencies than monocrystalline options, but the advantage is a lower price point. In addition, these panels tend to have a blue hue instead of the black hue of the monocrystalline counterparts. Polycrystalline solar panels are also made of silicon. However, instead of using single crystals of silicon, manufacturers melt many fragments of silicon together to form wafers for the panel. Polycrystalline solar panels are also referred to as multicrystalline or many-crystal silicon. Because there are many crystals in each cell, there is less freedom for the electrons to move, and as a result, polycrystalline solar panels have lower efficiency ratings than the monocrystalline panels. Now we'll take a look at on-roof solar panels, often referred to as bolt-on systems. On-roof systems were the first generation of residential solar panels. On-roof systems consist of a set of solar panels attached to a roof by a mount, which is bolted onto the rafters. With on-roof solar installations, the mounting system installation instructions recommend notching the roof tile around the roof to ensure it doesn't disturb the plate. Modifying this crucial penetration point means susceptibility for water ingress and will also invalidate any of the roof tile manufacturer's warranties. Installing on-roof solar also adds additional weight to the roof, which puts unnecessary strain onto the structure, which may not have been tested. And at roughly 20 extra kilograms per metre squared, this could have some potentially serious consequences. The installation of on-roof systems occurs on a completed roof, and as roof tiles are not designed to be walked down, there is an increased likelihood of damage due to hairline cracks as a consequence of foot traffic, and this only becomes evident 9 to 12 months following pulley reaction and weathering. Bird nesting can also cause issues. Birds like on-roof solar panels are placed above their nests as they protect them from the elements. As solar arrays only work to the least efficient panel, pigeon droppings and nests could cover one part of the panel, affecting the energy produced over the whole system. Without adequate prevention methods such as mesh around the perimeter of installation, which will come at an additional cost, this can be a recurrent long-term issue. As mentioned previously, bird nesting is a significant problem when it comes to solar. Not only does it affect efficiencies through the bird nest created on the panels, but also the nest beneath, creating heat spots and potentially blocking gutters upon the roof. Other pests such as rodents have also been found nesting on the panels and even chewing cables. This therefore does not only require more maintenance throughout the year, but also maintenance could create further problems from walking on the tile and also create significant further costs to the tenant and the homeowner. Now we're going to have a look at roof integrated panels, which are designed to be incorporated into your roof surface. Thermal opening is an MCS 012 approved building material, and therefore when installed will replace a section of your tiles. Roof integrated PV systems are installed as an integral part of the roof. They perform as a building product, protecting against wind, lift, weather and other elements, and are usually installed at the same time with installing or replacing a roof. This makes them ideal for house builders, landlords, re-roofing schemes, and also self-wall projects. As both PV and tiles are installed together, with PV parallel to the tiling, it means there's no modification to the roof tiles, securing the validity of the warranty. There is no discrepancy that even though on-roof systems are sleeker than ever before, they hold no comparison to the aesthetic of roof-integrated PV. The simple fact that the tiles are concealed within the body of the roof, often in the same or a similar shade of the roof surface, makes them a lot more visually pleasing than the bulky look of on-roof mounted tiles. Roof-integrated systems make it easier to pass difficult planning conditions and can even be used at heritage sites as they do not detract from the aesthetic appeal of the building's facade. There are numerous integrated solar PV solutions on the market in the UK. The majority of the systems require a carrier system for the panel to sit into. These tend to be manufactured from polypropylene trays. PV panels are then placed and fixed into the trays. The trays provide adequate ventilation for the panels and weather tightness to the roof. The main disadvantage of these systems is they require additional timbers to fix to, and often wider timbers of 100mm plus. They also recommend and prefer counterbuffers to be used. They're often less expensive to buy, but once the additional battens and labour has been taken into account, they're not as cheap as originally advertised. If the customer and specifier is concerned about fire, they do provide a tray which is fire retardant, but this can be at a higher cost. The panels for this system are then manufactured by another party, which questions how the two products work together. Have the panels and trays been adequately tested for wind uplift and fire resistance? This is something that specifiers and installers really need to investigate before choosing this system. Another integrated option is the Marley solar tile, which is designed to form part of an integral part of the fabric of the roof. Fixed directly onto the battens to replace a section of roof tiles or slates means a completely flush fit can be achieved to provide a sleek, unobtrusive roof finish. What's more, with no space behind the panels for birds to nest, the Marley solar tile remains a very low maintenance, high performance solar solution. Solar panels themselves are subject to degradation in a variety of ways. However, due to a lack of moving parts within the system, a solar tile can be classed as a fit and forget product with very little maintenance required once installed. To support this, we offer a 15-year product guarantee when used with the full system. However, our solar tiles are also backed by a 25-year manufacturer's guarantee, which means the panels will still be performing at 80% of its original efficiency after this period. Surveys via which found that wind causes one of the most common issues with solar panel breakages. The Marley solar tiles provide excellent weather tightness and wind resistance without the need for extra roof batten support, adhesive flashing rolls, or fireproofing materials. The certified wind resistance for the Marley solar tile is more than 4 times higher than competitive PV roof tile products and is suitable for even the most exposed locations. The Marley solar tile is the only roof-integrated system accredited with the highest resistance to spread of flame and fire penetration in all European safety tests, achieving the B roof T1, T2, T3 and T4.
Okay, so by adding PV to your property, you can immediately improve the EPC rating and often can increase the grade you receive into the next band. For example, a 4 kilowatt system can add up to 15 points to your EPC rating, meaning if you start at a low level E, after installing PV on your property, then you would achieve a low level C. PV is also able to produce property's energy. A well-sized PV system can cover a significant proportion of the building's annual electricity usage, in many cases 65 to 70%. Homes account for around 20% of the UK's GHG emissions. Eliminating these emissions is essential for reaching net zero. Domestic Energy Performance Certificates, EPCs, have now become a critically important policy tool for delivering net zero. Many of the government's policies rely on EPC ratings as a means to drive and measure the energy efficiency improvements and low carbon heating in existing homes. The cheapest and easiest way to improve an EER rating is to fit a more efficient fossil fuel boiler which will reduce fuel consumption, or to install a PV system which will reduce or offset electricity consumption. So let's look at PV as part of a fabric-first approach. This approach considers a broad range of aspects: your comfort, your home and its history, indoor air quality, ventilation, moisture inside your home, energy usage and bill reduction, as well as CO2 emissions. This holistic view helps identify your options and how they can work together. It also reduces the risk of unintended consequences. For example, if a home becomes well insulated and more airtight, but the ventilation strategy is not upgraded to provide the right ventilation levels, then risk of mold-related issues increases. By adopting a fabric-first principle, we prioritise energy-saving measures first, in order to make our homes feel more comfortable and affordable to heat. This is before we start considering changing to heating and water systems. Prioritising fabric first includes reducing upfront capital heating and system costs, improving insulation performance of the home as a result for smaller boilers and radiator requirements, which means lower running costs. So first we look at remediation work. Before any improvement is carried out, it's essential to make sure the property is being fixed and the house is in a good state of repair. This extends the lifespan of any work to improve the house for as long as possible. The next is the installation. Once the existing issues are fixed, the floors, fabric, walls, roofs and floors should then be improved to reduce the loss of heat. This can be done by adding insulation. Then we address air tightness. Air tightness is essential for a comfortable, draft-free and energy-efficient home. Improving this means removing all gaps, cracks and unwanted openings in the external envelope of your property, which comprise of roofs, walls, windows, doors and floors, in order to minimise leaks and drafts. If replacing the roof or fixing the roof at this point, PV should be considered as part of the roofing works. Ventilation. Insulation increasing air tightness in a house makes ventilation a key consideration for retrofit work. Good energy is essential for the health and comfortable of the house, reducing stuffiness and maintaining the health of the residents. It is also essential to deal with excessive humidity, which if not controlled can lead to condensation, damp, mold and other health problems such as respiratory illness. Appropriate controlled ventilation is required to maintain a good relative humidity levels within the property. So the building and service of renewable energy. Once the house is better insulated and less fuel is being used to heat the building services, hot water, electricity should then be made more efficient. Once the heating demand is lowered and the house is better fitted, the potential for renewable technology should be considered. Examples of these measures include solar panels, energy-efficient appliances, radiators, underfloor heating, hot water cylinders, heat recovery technology, replacement of boilers, and air and source ground pumps. So now let's look why we should consider solar as the renewable technology. Solar is a cost-effective solution that utilises space on a roof that is otherwise unused and can be added easily to the exterior of a building. PV performance is not affected by other fabric upgrades. So for example, if you don't have a well-insulated building and add an air source heat pump, this pump won't work efficiently. This is not the case with PV. A Which survey found that 94% of houses that have had solar installed found the installation had a minimum disruptive, and they would recommend having PV fitted. It is considered less disruptive than having an air source heat pump fitted, which is a key consideration when thinking about tenants' experience. PV is quick and easy and as a standalone way of improving an EPC rating of a property. It will reduce the cost of your energy bills and help reduce fuel poverty. As PV is simple to use, it requires minimum changes to the tenant's lifestyle, and batteries can be added at a later date as and when required. If you go for a system such as Marley, we offer a maintenance-free option. Once the PV installed, it doesn't require any annual checks or maintenance. PV also has a long lifespan, still working at its 80% efficiency after 20 to 25 years. And now with landscape and portrait options available, PV is suitable for the majority of roofs. So let's have a look at things you need to consider before selecting PV for your works. We need to look at external factors. Ecological location, shading on the roof, such as TVs, aerials, trees, etc., and planning restrictions need to be taken into consideration. Also, the suitability of the roof, the pitch, the orientation, and the size and design, and the weight of the product being added need to be looked at. As we've mentioned earlier, fire rating is always a concern when considering PV, and it's vital you choose a PV system with the highest possible fire and health and safety ratings. You also need to check that all components have the same performance in these ratings. Speaking to a manufacturer such as Marley will help you ensure you're sourcing a full system. There are a high volume of tray and panel integrated systems on the market that are unable to offer the Class 2 health and fire rating. Supply chain again is important. This is a real important consideration to make sure you have a supply chain agreement in place to meet the requirements of your project. And it's even more important if you're on a tight time schedule due to restrictions of funding such as the Social Housing Decarbonisation Scheme. With the recent changes to Part L driving high demand for renewable technologies across the new build sector, it's important that you have a supply chain in place to keep your projects running to time and on schedule. Having an MCS accredited contractor also plays a key role in keeping the scheme going to time. By using an MCS registered installer, you are ensuring a PV system is installed to industry standards and that the tenants are able to access the Smart Export Guarantee. One final thing to consider is the DNO. When installing PV or any form of electrical generating products on a property connected to the grid, the local DNO will need to be informed. Depending on the size of the system, this can either be done retrospectively or prior. If prior permission is needed, it can take up to 11 weeks to be granted. Because now we're going to have a little look at some of our case studies.
This case study is for one of our clients based in North Wales. Adra is responsible for 6,800 properties and support 15,000 local residents. Embarking on its own sustainability journey, the social housing provider needed an effective PV solution for the roofscapes of 2 new semi-detached properties constructed in Gwynedd. A total of 12 Marley solar tile panels were specified across the 2 properties, with the objective behind the product choice ensuring that the tenants would have access to a clean, sustainable and cheap energy source to support their daily lives. We worked with the Adra team on their initial specification and drawings. This entailed providing technical expertise on achieving the required power output from the solar panels, and we also provided practical help and training on site to support the installation phase. In this project, the solar tile solution sits alongside natural slate roof tiling as a fully integrated and aesthetically appealing solution. Paul Painter from Adra stated that they expected to apply such technologies to other ongoing new build or refurbishment projects, and collaborating with experts such as Marley really does make a significant difference.
And the next one we're going to have a quick look at is the Halton Housing Decarbonisation Funding Scheme. So Halton Housing carried out significant investment in work on 3 low-rise blocks of flats in the Grange Estate in Runcorn as part of a pilot scheme with the help of the government grant for the Social Decarbonisation Fund. 3 blocks have had improvements such as lower energy lighting, new installation, moderate controllable heating and PV panels added. Also a central ventilation system, new windows, external doors and enclosed balconies and an increased security system. As a result of the improvements, the carbon emissions have been reduced and the people that are living in the upgraded properties have seen a significant saving on their energy bills. Marley supported Halton Housing throughout the specification and design and supported the roofing contractors throughout the entire project. Marley were involved in delivering all the calculations and specifications, ensuring the correct number of solar panels were installed on the roof, delivering the required solar output for the residents in each block.
So our case study seen Marley's full pitched roof system with integrated solar panels installed on over 154 homes, and surveys have already taken place for a second larger phase. Roof refurbishment is an important part of Denbighshire Council's programme of external major repairs and energy efficiency improvements to its older properties. One of the biggest challenges is to bring the roofs up to modern standards in a cost-effective way while retaining the original aesthetics. As well as requiring a like-for-like replacement for the old clay tiles, the council also needed a pitched roof solution that would minimise maintenance costs, reduce the likelihood of future repairs, and incorporate solar technology to help the tenants cut energy bills. Specifying a full roof system rather than just the tiles has given Denbighshire Council long-term assurances about the performance of the roof. It also reduces risks by ensuring that all of the roofs have the same high level of quality, compatibility and compliance with the latest standards, and the council has a single point of liability. As well as reducing ongoing maintenance costs, it also offers tenant benefits by minimising the chance of roof problems, such as condensation and leaks, while helping local authorities to meet the Part L carbon reduction targets and cut tenants' energy bills by up to £260 per year. Katrina Allen, who is the Decarbonisation Housing Manager at Denbighshire Council at the time, added that the project has made a real difference in helping to make our council homes more energy efficient in times of rising fuel costs, and is already giving residents more control over their electricity bills. We'd like to thank you for your time today, and hopefully now after the presentation you've got a broader understanding of the available options within the PV market and how it can be beneficial towards your projects going forward.